Newton's first law describes something about objects, their inertia. To begin examining this, let's look at this little question here. We have two astronauts in space doing spacewalks, and one's trying to push a 50-kilogram ball, and one's trying to push a 500-kilogram ball. And the question is, which would be harder to push? Well, the answer is obvious, but the reason might not be so obvious. B is obviously harder to push. The reason is it has more mass. Now, Newton said that if an object has more mass, it has more inertia. Inertia is the resistance to change in motion. Now, if these two things are stationary, these two balls, we can describe their motion, and it may seem odd, but we'll describe their motion as stationary. It's not moving. That's a very valid kind of motion. And this larger ball with more mass has more resistance, more inertia. He doesn't want to move. It's harder to get him to move. He has more inertia, more resistance to changing his motion away from stationary. Now, the classic example of this is the old tablecloth pull. Before this guy pulled this tablecloth out, it was sitting here on the table underneath these objects. Okay, here's what happens. When the tablecloth is pulled, these objects do experience a force. It's friction of the tablecloth coming right through. It'll exert friction. But they didn't move much, did they? What happens is the plate's inertia, their mass, resists that motion. Now you see a little bit of motion here. They might shake, okay, because of that force, but they didn't move much, did they? Their inertia prevented that motion. The plates did not move very much. Now notice here I put some masses on here. Didn't we say earlier the more mass, the more resistance to motion, a change in motion, and that's inertia. Which one will resist most here? Sure. The table, let's see, the candle holder and the candle itself has 1 kilogram of mass more than those two. It has the most mass. It has the most inertia. It'll move least because it has the most inertia. In fact, when I do this sometimes, I put silverware on the table, and a knife, fork, and spoon. They have a lot less mass, don't they, than plates and cups and things if they're drinking glasses? Sure, they have very little mass, very little inertia. They'll often fly right off the table. So I usually have to wear goggles to protect my eyes because they might fly off and hit me in the eye because they have so little mass that friction force from the tablecloth will cause them to move. They have little inertia. Now that's about all you need to know for the MCAS. Let's go through this fairly carefully though. Inertia. Objects resist changes in their motions. I could say they don't want their motions to change. Here's the key. More mass, there's more resistance to that motion. That means there's more inertia. And these two pictures, this ball here had much more mass, so he had more mass, more inertia, more resistance to changes in motion. Harder to get him to change his motion to move. Here, this one had the most mass, so the force of friction, that was the hardest one to move. He had more inertia, sorry. It didn't want to move. Inertia is resistance to change in motion. Here's your video code. Bye.